Right, in this video we're going to look at basically an introduction to graphing linear equations that have two variables. And the first thing we want to talk about is what a rectangular coordinate system is. And basically a rectangular coordinate system is made up of two number lines, a horizontal number line and a vertical number line. And it's broken into what we call quadrants. The first quadrant will be right here, the second quadrant, and when we name the quadrants, we actually go counterclockwise. This would be the third quadrant, and this would be the fourth quadrant. And then we have two what we call axes. The horizontal axis we call the x-axis. And the vertical axis we call the y-axis. And what we want to do is be able to plot points, and in order to plot a point we have to basically be given directions on where to go, and the way we do that is to use what's called an ordered pair. And an ordered pair has an x-coordinate and a y-coordinate. Okay? And each ordered pair names exactly one point. And so the first coordinate, and the reason why it's called an ordered pair is generally the x-coordinate goes first and the y-coordinate comes second. And the x-coordinate tells you how to move left and right, and the y-coordinate will tell you how to move up and down. Where the two number lines meet is called the origin, and the origin has an ordered pair of 0, 0, meaning your x-coordinate on the x-axis you're at 0, and on the y-axis you're also at 0. So we're going to start by just plotting some points. And these are ordered pairs. I'm going to start with example 1. And so this first example, 2, 5, means you always start at the origin as your reference. And the ordered pair 2, 5 means to go to the right 2 and up 1, 2, 3, 4, 5. And that would be your first ordered pair, and we'll name that A. So the first coordinate tells you to go left or right, and since it's positive, you're going to go to the right. The second coordinate tells you to go up or down, and since it's positive, you're going to go up. All right, let's look at the second ordered pair, which is 6, negative 3. So the first coordinate is positive, so I'm going to go to the right, but I don't put my pencil down yet. The second coordinate tells me to go down 1, 2, 3, and I put my point. It's B. The third coordinate is negative 5, negative 3, meaning the first coordinate tells me to go left negative 5. The second coordinate tells me to go down to negative 3. That would be the ordered pair. Now 0, 9, when the x-coordinate is 0, remember you're starting at the origin. The 0 in the first coordinate tells you you don't go either left or right. All right? You just start, you stop, no left or right, but you're going to go up 9. It's going to be right here, and that would be D. And then the last ordered pair, the y-coordinate is 0, and the x-coordinate is x, so it tells us we need to go to the right 7, and then since the y-coordinate is 0, it means I don't go up or down, I just stay right where I am, and that would be E. So if you want, if you've never done this before, and you want to try this student practice, pause the video and plot the ordered pairs, and then start the video up again and check your answer. So take a minute and just look at your, just compare your answers to mine and see that you've done that correctly. All right, so now we're gonna look at some ordered pairs or some points that are already graphed. or you're given the point, you want to find the ordered pair that goes with it. To find your x-coordinate, you just draw a perpendicular down to the x-axis, and that's going to be where you hit is going to be your x-coordinate. And to find the y-coordinate, you draw a perpendicular line to the y-axis. So that's going to be 2, 5 for A. For B, it's on the x-axis, right, which means we've gone over 5. Right, we're at 5 on the x-axis. Since we haven't gone up or down, the y-coordinate is 0. And any ordered pair, any point, that's on the horizontal axis or the x-axis is always going to have a 0 for its second coordinate. C, if we want to get our x-coordinate, we go down to the x-axis, so we get -3. And to get our y-coordinate, we draw a line over to the y-axis. That would be 4. For D, draw that perpendicular line up. That's going to be 1. And then to get your y-coordinate, go over to the y-axis. That's going to be -6. For E, we're on the x-axis, so anytime you're on the x-axis, you know the y-coordinate is 0 because you didn't go up or down. And we're at -7 on the y-axis. And then the last ordered pair, the last point is F, and we're on the y-axis. So anytime you're on the y-axis, your x-coordinate is 0. You didn't go left or right, but you went up 9. So this is how you plot points, and how you, given a point, you can name the ordered pair that belongs to it. Now what we want to do is we actually want to look at, what is a linear equation, and we'll look at one method of graphing linear equations, and that method is by making a table of values. Okay, so the first thing, we're going to look back a little bit here before we solved linear equations in one variable. So we had something like 2x minus 3 equals 5, and this equation has one solution. It's x equals 4. And a solution to an equation like this is the value of x that, when substituted for the variable, makes the equation a true statement. So this is what we've done already. But in this section, we're going to look at linear equations that have two unknowns. And so we're going to start off by looking at two forms of a linear equation. And the first one is ax plus by equals c. And this is called standard form. The other form is y equals mx plus b, and this is called slope-intercept form. Now, we're not going to talk about why it's called slope-intercept form in this video, in this section, but we will look into this a little bit later in the chapter. For now, we're just going to focus on these two forms, and we're going to graph a line. But before we do that, we're going to look at some solutions to linear equations in two variables. And just in general, when you have an x and a y, you've got a linear equation in two variables. The solutions are going to be in the form of an ordered pair. You're going to have an x value and a y value, where before, when you only had one unknown, you only had one value as your answer. You just had an x value. So the first thing we want to do before we actually graph a line is to check to see whether an ordered pair is a solution to an equation. So we'll start off by checking the first ordered pair. And we know that the x-coordinate is first and the y-coordinate comes second. So we're going to just, wherever we see an x in that equation, we're going to put the 2. And it's going to be minus 5y. So we're going to put in a 0 for y equals 8. And so you substitute both values, and then you evaluate. And we get 8 minus 0, which is 8. And since 8 equals 8, we know that that ordered pair, 2, 0, is a solution to that linear equation. All right, let's look at the next ordered pair. 1 and then -4/5. So the 1 is my x-coordinate, so I'm going to put that in wherever I see a 1. Minus 5 times 4/5. 4/5 is my y value. And see if that equals 8. So we get 4. These cancel. And I'm sorry, that's a negative 4/5, so we put a negative in there. A negative times a negative is a positive, so it would be positive 4. And we get 8 equals 8. So this is also a solution to this equation. Now remember, when we were solving linear equations with one unknown, there was only one x value that was a solution to the equation, unless it was one of the special cases where there was an infinite number of solutions. But down here, all linear equations have an infinite number of solutions, and those solutions happen to fall in a line. And those solutions are in the form of ordered pairs. So let's check this last ordered pair and see if it is a solution. So 4 times 3 minus 5 times 1 equals 8. So now I get 12 minus 5, which is 7. And 7 does not equal 8. So this last ordered pair is not a solution. This is a solution, and this ordered pair is a solution. All right, in the next video, we're going to look at a linear equation where instead of checking to see if an ordered pair is a solution, we're going to find, we're going to complete an ordered pair. Given one value, we're going to find the other.